This is WellSeeker Pro training, and this video will be covering directional drilling tools. So effectively we'll be covering some different scenarios that are relevant to directional drillers, and we'll show you the functionality within WellSeeker Pro that will assist directional drillers in their day-to-day tasks. This will include tools that are specifically related to visualizing the wellbore, survey management, and anti-collision. We will not go into things that cover daily reporting, slide sheets, and other things like that. So this is purely about the functionality of the basics of directional drilling. Okay, so at the start of a job, the position a directional driller will normally find himself in depends upon the company he's working for and their policy. There are a number of scenarios he can find himself in. He might have arrived at site with a blank database. He might have arrived at site with a database for WellSeeker Pro that's already got all the information that he requires in it, that may have been loaded on the laptop. In that case, you don't have anything to worry about, all the information's there. In the prior case, where you've got a blank database, there are a few things that you can do to get the information in there. One is if you've got like a PDF or A4 report, you can manually input that information through the database levels and create your structure. That's quite labor intensive, so there's a couple of import methods you can use. One is using a WellSeeker Pro export file and importing that to populate all your information. The other is taking a Compass export file, an EDM file, and importing that. Will also create your database structure. The final option is if your company utilizes a server database, you'll be able to use the remote data fetch functionality to pull the relevant well data down to your database via the internet. None of those options are covered in the scope of this training. That is covered in a separate training video. So what we'll do in this case is we will go to the training material that came with this video, and we're going to select the database that already contains this relevant information. So I've currently got it open, but for the purposes of this exercise, I'll show you how to go, File, Select Database, and select the database that came with this video. So DD Training Database, and select Open. Okay, this then opens that database within WellSeeker Pro. So WellSeeker Pro is now looking at that database for all of the information it will be utilizing going forward. Once you have a database open, the next thing you should do is verify that you've got the units set correctly. Okay, so in this case we're going to use US unit set. Okay, so we're now in a position where we have our database tree information populated. I'm going to expand the database tree by left clicking the plus symbols, or you can do that by double left clicking on the title as well. The well of interest for us in this example is going to be 3H lateral. You can see we've already got a plan for this well in place. So normally as part of your job you'll do some form of verification to make sure the information you've got in your WellSeeker database is the same as the well planner who sent you this information intended. So you may have an A4 planning report, a plot printout, something like that you can verify various data against. Normally I would open up the plan by double left clicking. This will display my plan, and I would go ahead and check the bottom line of this plan matches the bottom line of what the well planner's planning report has in it. As a good start. That verifies that your coordinates reference system is set up correctly, your tie on line set correctly, and that your end location are all tying in. Okay, I wouldn't just check the local north-south coordinates as well, I would check the grid northings and eastings, and again this ensures that your coordinates reference system data has been set up correctly. You can, in addition to this, go checking through all the different levels of the database tree with a fine-tooth comb to make sure they match the well planner's reports, but that won't be covered in the scope of this particular video. Okay, so next thing, once I've opened my plan, I can see it's there. Next, I'm going to go ahead and look at visualizing this plan in relation to the other wells that we have in the database tree, i.e., where is this going to be in relation to our offset wells? The best place I find for doing that is in our 3D plot. So I'm going to have my plan open and select my 3D view, or go to plots and select 3D view from here. Both do the same thing. You can now see that I have my plan visible on its own, and we also have a lease line that's been input in the database for us. Okay, so we can see our plan and how it relates to our lease lines, but we can't see how it relates to any offset wells yet. So we're going to have to tell the software what wells we want to see as the offsets. To select your offsets, have your plan selected and go to Select Offsets. Okay, from here, effectively you'll be able to see your database tree. If I hit Expand, this will open up my database tree and all the levels. You can filter how much you see of this database tree using these filters here. So I'm not interested in non-principal plans, I'm only interested in principal plans and actual wells. So I'm going to uncheck Include non-principal plans and hit Expand again. And now all of the non-principal plans have been filtered out. So I'm going to go ahead and select any well that's got a actual well associated with it. I will select the actual well and ignore the plans because the actual wells are the things we're interested in. If there's no actual well for the well, I will then select the plan. So in this case, 1H has an actual well, 2H has an actual well, 3H is our well, 4H has an actual well, 5H has an actual well, 6H has an actual well, and then 7H and 8H are plans. Now the reason we include plans is obviously you don't want to cut off any slots for future wells being drilled. If I hit Apply, then go back to my 3D view, I still can't see those offset wells. But I know I've just selected them. The reason behind that is next to your Select Offsets button, there is an Offsets toggling button. So in this case, I'll select that, and now we can see all of our offsets. Okay, so right now we can see our plan and all our offset wells and plans on the pad, but the information we have here isn't overly useful in terms of we can't see really close up where the distances are. You can zoom in and out using the mouse scroll button, but the best way to utilize this 3D view is to right click on the plan and center on survey. What this does is it zooms in on a point of your reference well, in this case the well which you opened the plot with, so in our case the plan for 3H. Next thing I would do is right click and select Show Closest Approach. Okay, and this draws a green line to your offset well. In this case our offset well is displayed up here is 1H. So what does this allow us to do? The current point we're centered on our reference well is denoted here. So this is our survey point at 17800 and the coordinates for that. Below that is the distance information to our offset. So we're currently high side referenced and we're up, down, distance, left, right distance, and center to center distance from the offset from our current point. Okay, so that is useful information. We can keep our reference well the same but cycle through the different offsets by following this instruction here using the greater than or less than symbols. And that allows us to move our green line between various different offsets. You'll note the coordinates information, and you'll note that the distance information here updates based upon that. Okay, I'm going to leave it on 2H because this looks to me, from eyeballing it, this part of the well probably the closest offset. Okay, we can also change this point of interest by moving up and down our reference well. We use the up, down arrow keys on our keyboard to do that. As you'll see, as we change our point of interest, so too does the closest center to center point on our offset well. Okay, so you can see very quickly how using the 3D view will become a very powerful tool. Okay, so right now, when we zoomed in, we're at the bottom of our well. What if we wanted to check out what's near the top? We could just move all the way up, but it takes a while to get to the top. If I right click and go to top of well, it takes me right to the top of the well. If I want to get back to the bottom, go to bottom of well. Additionally, you can zoom in and out using the mouse central wheel button, and if not, you can use the plus and minus keys on your keyboard to zoom in and out. Like all the charts, the 3D view chart is very user definable, and that's definable from in the chart properties. Now, we're not going to cover these in great detail because they're covered in a separate course, but we will go in and look at how to adjust our worksite and our compass ring within the chart properties. Okay, and when I say the worksite and the compass ring, I mean these bits here. Okay, so it's actually made up of two components. The compass ring being this black ring with north, south, east, west on it, and the worksite being this one with multi-radial rings on it in relation to high side in this case. Okay, the way we adjust the layout of this compass ring and worksite is we open up the chart properties. To do that, you either go to this icon here when you've got a chart selected, or you double left click on the chart area itself. Okay, this is the chart properties dialog. The section we're interested in here is the 3D chart specific section. So we can adjust the size of the survey sphere, of the fly down sphere. We can change the colour of the worksite and whether it's visible or not. Change the colour of the compass or whether it's visible or not. We can also change the radius of the worksite. Depending on what distances you're interested in, you can change these. So I'm going to change this to 25 and 5 for a smaller worksite. Also have the option of showing the rig symbol on top of the wellhead for your reference well. You also have the option here of selecting the colour of your text that you have in the 3D plot. Okay, so if you were running a dark background, you could have those changed to white, for example. Okay, so you can see here now I've changed the radius. It was 50, it's now 25 with increments of 5 for my worksite, and I've left the compass ring unchanged. Okay, so that's some 3D specific chart properties. Something to point out while we're here, again, this is covered in a separate course, is you can set up the default settings for all your plots in chart defaults. Okay, this will then be saved to your specific computer based upon your setup file input settings. So this will allow every time you open up a plot for the first time to have saved settings in there and how you view things. Okay, now that we've looked at how to adjust them, we'll actually discuss what these are useful for. So the worksite itself is useful for when you're zoomed in and out, retaining a sense of scale and distance. So this is a physical radius from our well centre or plan centre. Take us down to a place where there's a bit more inclination in the well, because the compass ring is actually a very good way, irrespective of where you are in terms of relation to the well, it gives you a sense of horizontal. Okay, so for example here, we're zoomed right in, we've lost our bearings entirely, but it allows you to know which way is north, south, east and west, and where horizontal is by its orientation. Okay, so that is the use of the worksite and the compass ring combined. Okay, so once I've eyeballed my plan in relation to the offsets, I would then go ahead and open up my separation factor plot and center distance plot to find out which are really the wells that I need to be aware of before I start drilling. So in order to do that, I reselect my plan tab and I open up my separation factor plot. Okay, again, any offsets that we had selected in the offset selector here are going to be displayed in this separation factor plot scan. And right now it's hard to discern what is what, so in order to figure out what the offsets are, we are going to select our screen reader from the toolbar. Once that's selected, when we hover over a series on the chart, we can see that 4H at 500 feet measured depth gets down to a separation factor of 1.31. Okay, all of these values, because it's an anti-collision separation factor, are affected by the anti-collision setup options. Again, this is discussed in a separate training session, but it's something to be aware of when you're looking at these results. Okay, so that looks like the only well that is of a reasonable concern to us in terms of separation factor. So we can go back to our 3D plot and look at physically where 4H is when we are at 500 foot measured depth. So I'm going to go back to the top of the well and just scroll down to 500 foot. Change that text back to black. You can see it more clearly. Okay, so we're at 500 foot. I'm going to change my offset well to 4H. We can physically see 4H here. In terms of center to center distance, it doesn't really look any different to 2H. Okay, and we can verify that by next selecting our plan and opening up the ladder plot. Okay, so I'm going to zoom in on the point of interest using my mouse central scroll wheel. I'll just use the up and down arrow keys to move around. Okay, so I'm zoomed in quite close there. We can see there are two wells, two series here. So again, to find out what those are, I suspect those are 4H and 2H. That is 2H there. And you have to pick an actual point of intersection, and 4H, yes. So again, both of these wells round about 15 foot away from us, centre to centre distance. So in terms of centre to centre distance, both wells are of concern shallow, but based upon separation factor, 4H is the more critical. And that will almost certainly be down to the way that that well has been set up in terms of IPMs, and it will have bigger ellipses of uncertainty as a result. Okay, so what we've effectively covered is quickly verifying our plan data, visualizing the plan within 3D view, turning on some offsets, eyeballing where those offsets are in relation to our well, and then looking at the physical center to center and separation factor values for our offsets in relation to our plan before we've even started drilling. I'm going to close down the ladder plot and the separation factor plot. One thing that is quite common when you arrive at the rig site, you have a plan related to a specific depth reference that was used in the planning stage. But when you actually get to the rig site, you find out that the depth reference has changed, i.e. the ground level to rotary table elevation the planning department given was incorrect. It's actually something else. Or in rarer cases, that the ground level to mean sea level value has changed. Okay, we're going to cover a scenario where the ground level to rotary table elevation has changed from the planning phase to when you arrive on the rig in reality. So we've currently got our plan 3H here. Where you select your depth reference is in your plan properties. Okay, in your depth reference, and that's selected from a drop-down menu. Now what we can see here is I have default RTE and RTE2 available as options. Okay, so I have my plan here, and where the depth reference for my plan is saved and selected is within our plan properties. So to get to that, I select my plan, left click, and then select my properties, or alternatively right click and go to properties from the right click menu. Okay, in here we can see our depth reference, and currently we've got a datum or mean sea level to the rotary table of 333.02 feet. Okay, and we only have the option to select from default, which would be 0, or RTE, which we've currently input. We don't have the option of selecting another depth reference at this stage. Where we have to go to create that additional depth reference is at the wellhead level. Okay, so I'm going to close my properties and go to my wellhead level and open the properties for that. Okay, in here we have the depth reference section, and this allows us to put in multiple depth references. This is intended for allowing you to adjust depth references based upon the rig that comes on location, or any changes that may occur in what is known about the ground elevation to system datum, in this case mean sea level. So the scenario we're going to run here is that the well was planned on a rig with an air gap of 23 foot, but in reality we've got to the rig site and actually the air gap is 33 foot. Okay, so we're going to call this RTE2. We have to go ahead and create this additional datum. And our new datum will be 343, i.e. an additional 10 foot. Okay, still the rig, just the incorrect information was given to our planning department. and I'm going to select this as my default depth reference. So all that means is it's not going to change anything here, but if I created a new well, this is the depth reference that will get utilized. Okay, I've created my datum to mean sea level value here, i.e. rotary table to mean sea level, but I still need to input some data when this row is selected. You can see here it thinks the air gap is 343.02 feet at the moment. Okay, so I'm just going to check what the ground elevation actually was above mean sea level. It's 310.02. I'll just copy and paste that over and hit apply. Okay, so now we've saved this new depth reference we've just created with an air gap of 33. This will now be, when we go to our plan properties, selectable from the drop-down menu. Okay, before we go ahead and do that, we just have to be aware of certain things. So I'm going to select RTE2, and we get this warning. Okay, a datum currently in use by one or more actual wells is being changed. Do you wish to change the TVDs to reflect this or preserve the original TVDs? This action can seriously corrupt your designs. Effectively, what this is warning you about is you've just changed your depth reference by 10 foot. Do you want to update your measured depth and TVDs to reflect that change but keep your TVD subseas the same? Or do you want to preserve your TVDs and change your TVD subseas? Okay, so those are the two options you've got here. Depending on the circumstance you're in, you will choose one or the other. Generally speaking, and I verify this with your well planner before doing so, they will want to keep the TVD subseas the same because those are the physical geological targets that you're trying to hit. That's what they're referenced to. So changing your MD and TVD is what you want to achieve whilst maintaining the TVD subseas. So in order to select that option, I'm going to change TVDs. If I select that, you can now see that our measured depth jumped by 10, our TVD increased by 10, but our TVD subseas for everything other than the tie-on line have remained the same. I.e. the geological targets we were hitting before based upon TVD subsea are the same now as they were then. We've just updated our local depth reference based measurements. Okay, so that is how you would go about updating a depth reference when you're in the field. You'd first create that updated depth reference in the wellhead properties, and then you would select it from your plan properties and make the correct choice in terms of changing your TVD or your TVD subsea effectively. Okay, I'm just going to quickly revert my plan back to how it was before we progress. Okay, so this is the plan as it was originally. Something else that can be tweaked at the plan stage, although this will normally happen whilst you're drilling the well, is we can make an offset plan, i.e. a plan that adjusts a particular part of the plan by a certain amount of TVD. If you want a perfect plan change, you would have to get that done by your well planner normally. But if, for example, the geologist has come to you and say that the land-off point for the well needs to be 10 foot deeper, you can do a very quick rough and ready plan change within WellSeeker Pro. In order to do that, you'd first select your principal plan. You would right click and go create offset plan. Okay. Next we want to choose the point at which we want to change the TVD, i.e. up until this measured depth the plan will be identical. Only from that point onwards will we be changing the TVD of the plan. So in this case I'm going to choose our landing point, which is at 11217 feet measured depth. And we'll just verify the information in this dialog matches what we have in our plan, which it does. Next, the geologist has asked us to make the landing point 10 feet deeper. So I'll put 10. If it was 10 foot shallower, you'd put -10. Okay, you can see the new TVD updates giving you the new value of the TVD for landing point. And the last value you've got here is dip. In here, you would input whatever you want the hold inclination to be. You don't get a variation to change the azimuth. This will be the azimuth that is in your plan already, but we can change effectively the inclination of hold. The alternative option for the Create Offset Plan dialog is TVD reference to 0 vertical section. So if I check this box, it will still take our start point value, but now it's not an offset. Okay, offset TVD, and now it just asks for plain old TVD. So now we just have to take a TVD value, and it will calculate our new TVD based upon this TVD value of 0 vertical section. And again, we input the dip value here. Okay, so I'm going to go ahead and keep my dip the same, and I'm going to hit create. Okay, so this is still my original plan open, but you can see here in the database tree we've now created a new plan. Identical plan name, but with TVD plus 10 dip 86.21. I'm going to open up that plan, and if we compare that to our original plan, we've got a couple of extra lines, and effectively it's got a vertical portion in at the land off point, which has dropped us 10-foot TVD. If we select our new plan and look at the section view, I'll zoom in and show you exactly what it's done. We zoom in on the landing point. All it's done is it's just taken the original landing point, and then for the rest of the plan onwards, it's just dropped us by 10 TVD, kept everything else the same. Okay, so that is what the offset plan tool is used for, and allows you to adjust the TVD of your lateral at very short notice. Okay, I'm going to go ahead and delete that plan before we carry on. So at this stage we've covered all the things you'd want to do pre-well. Verify your plan is correct and as the well planning department intended. You've visualized your plan to see what the risks are. You've verified it against separation factor and centre to centre distance plots. And we've also looked at the scenarios where you'd have to change a depth reference for your plan and how to update that, as well as creating an offset plan from your original plan to adjust TVDs for a plan from that point onwards. The next things we're going to cover are what you do when you're actually drilling a well. So we've got a plan at the moment, but we don't have a well. We don't have anywhere we can input surveys. So in some scenarios, your well planners would have already created this level for you in WellSeeker Pro, but if they have not done so, we'll show you how to do that now. If you right-click at your wellhead level and insert new actual well. So a new actual well differs from a planned well in the fact that this is one that you can attribute surveys to, and you build an actual well structure. With this video and the database that was provided, there was also provided an Excel document with a set of data. This is what I'll be using going forward. If the data I input doesn't match the data you've got, it doesn't matter, it just means the data has been updated at some point in the training documentation. So I'm literally going to be taking an Excel document and copying and pasting values over. So I'm going to copy and paste over the name. The vertical section azimuth and the magnetics data have already been pulled over. This is because we already have a principal plan selected under our wellhead level before we've created our actual wellbore. And if that's the case, these values will automatically be pulled from the planned well. Our depth reference has already been selected, and that's because we had this depth reference selected as default at our wellhead level. So at this stage, there is nothing else that we need to add for creating this actual wellbore. I'm going to hit apply and close. Okay, now that we've created our actual wellbore, if I double left click on the actual wellbore, there's no data here, there's no surveys, and I can't actually add anything in, it's all greyed out. That is because this table gets fed off of the information you input in your surveys tables. And this is your definitive listing window, effectively. So what we need to do first is right-click our actual wellbore level and insert new survey. I'm going to call this survey 1-surface. I'm going to tie it on from surface, because this is the start of a new well at surface. If you were tying this onto another survey, you would select from survey. This will be available from a drop-down menu, and when you select that, it will take the deepest survey point of that survey as your tie-on point. You can also select user-defined to input different values. Okay, once you've selected your tie-on point for your survey, you can also select your IPM, your instrument performance model. So in this case, I'm going to select MWD plus IFR1 plus MS. Okay, apply and close. If I double left click on my surveys now, we have an editable input format for our surveys. So this is a survey table. You can see that only the measure depth, inclination and azimuth columns we can input information into. Once you've input information in there, all the other columns in grey will get automatically calculated. Unlike the plan, the survey column has an up, down, left, right option available in it. And what this refers to is the distance it is from the principal plan. The principal plan is important because that is the plan that our surveys and actual wellbore are compared against. And you can tell what's an actual plan by the fact it's got a red box around it. Okay? If I go to my plan properties, this is where we select what is a principal plan or not. You can only ever have one principal plan selected under a given wellhead, i.e. the plan that is currently getting used and you will compare your surveys against. Okay, if I uncheck that, you'll see it's no longer highlighted in red. So that is how you physically verify which is the principal plan and which is not. Okay, so that's what the up, down, left, right values refer to. Within the survey table as well, you can also change the view, much like you would for the plan, by going to View and Survey Column Show Hide. Okay, you can turn on and off various different columns to view. Now I'm going to show you how to input surveys. So you can either manually do this by typing, or you can copy and paste from an Excel document. So I'm going to use the data set that's provided with the training. You select the surveys. Bear in mind we've already got the timeline in the software, so I'll copy everything below that. Copy or Control-C, and paste or Control-V, and that pulls it in. At this point you would save those surveys. There is another import method as well, other than manual and copy and paste. So I'll just delete these surveys to show that, and you go File, Import Survey Data. This will import surveys into whatever survey table you've currently got open. Next, you select what file type you are going to be importing from. So tab delimited, space delimited, comma delimited, or an Excel document. In this case it's Excel, and we're going to use our data set. When I select Open, we have the Import Survey dialog. Effectively, you've got to choose what columns and rows you want to import. So effectively, I want to start importing from row 5, and my end row is going to be row 40. Okay, once you've selected which rows you want to import, you have to tell the dialog what column relates to what value. So in this case we've got MD in 1, but that's just a record number. So we want to change that to NA. Row 2 is actually the MD. Row 3 is the ink, and column 3 is the ink, and column 4 is the ASCII. Next, when you're happy with your setup, hit Import. It warns you that it'll overwrite anything already in the table. Once you hit OK, it pulls it all in. So 3 different ways of getting surveys into your survey data table. One tool you can use once you have surveys in place and you've saved them to your well, you can use the interpolate function. So to do that, again, whatever table you've got open will be the thing that's interpolated. Go to Tools and Interpolate. In here you can then type in either a measured depth and inclination or a TVD, and based upon that the interpolate dialog will populate. Okay, so I'm just going to say 500, and that interpolates a value between 527 and 433 using minimum curvature and gives you the coordinates for that. You can also, instead of typing in individual interpolations, you can select Show Interpolate Listing, and you get to select the interval and the start and end depth of that listing. So here we're going from 0 to 3890, and it creates an interpolated listing every 100 foot. We've also got the include stations, so it includes all the surveys, and include final stations in there as well. If you don't want them included, just uncheck the options. Okay, so that's the interpolate dialog. You can export that data if required. That's the interpolate function. Now we input our surface section surveys. We'll break down and show you how to input the other surveys. So if we go back to our actual wellbore properties, you can now see, because we saved it, our surface surveys have been saved in the survey program. And when we open up our actual wellbore, i.e. our uneditable definitive listing, these have also been updated. And this feeds from the survey program. So in order to get our intermediate surveys in from the data set, I'm going to right click at the actual wellbore and insert new survey. Type in 2 intermediate. And I'm going to tie on from a previous survey. So as mentioned before, this takes the last point of the survey you select. And for this I'm going to use again MWD IFR1 plus MS. Hit apply. Now when I open this survey, our tie on line is the last point of the previous survey. I'm going to go ahead again and copy and paste from the dataset document and just Control C, paste, and pull those in. Hit save. Open up my actual wellbore properties, and again this has been added to the survey program. Hitting save adds this to the survey program. And this builds up our definitive listing. Next I'm going to create the curve survey table. Right click on the actual, insert new survey, type in 3 curve lateral. Tie on from the previous survey, so that's survey number 2 intermediate. This one again, same IPM. Open this up, and this time, so that we can run an exercise, I'm only going to take these surveys down to midway through the curve, so we can do an example. So copy and paste, and save where we are now. Okay, so what I'm going to do now is I'm going to take my survey, I'm going to open up my 3D plot, and I'm going to plot my offset wells and also, importantly, the plan. So again, to do that, we go to select offsets and we select the offsets that we're interested in. Okay, and for 3H, I will want my principal plan selected as well. I then turn them on, so the toggle button, and then I center on survey. You can see now I am in halfway through my curve section. I'm going to show closest approach, and we show a fair bit off the line in terms of from the original plan. So what I'm going to do at this stage is introduce you to projection tools and how we try and get back to our plan. So in order to access projection tools, we select our survey that's currently open, go to Tools and Projection Tools. We've got two sets of projection tools here, Multi-Project and Project Ahead. Because we're in a curve, we're going to start with multi-project. This top section we'll discuss later, but the specific part we're interested in for when we're in curve sections and landing off is this landing data section. First thing you do is select the critical point. This critical point listing is populated directly from the rows of your principal plan. So in this case we've got row 7 is our landing point, and what this does is it automatically takes our plan critical point that we've selected, and it tries to match the measured depth, the TVD, and the up, down, left, right, so that you hit the landing point bang on. However, this often comes at the cost of inclination azimuth. As we can see, these are massively out compared, particularly in inclination compared to the original plan. So what we can do is adjust TVD and adjust inc ASI. This will allow us to user define an acceptable inclination ASI. In this case, I'm just going to make them match the plan exactly. And this keeps the plan TVD, inclination azimuth, bang on what the plan was, but it obviously has an effect on the measured depth and the up, down, left, right values. So you've got to find a compromise somewhere that you're happy with in terms of inclination azimuth and the coordinates that you're actually hitting. Once you're happy with your landing method, you can also then view the dogleg severity. We also have the option to add in 2 additional projection lines in here. These are user definable, so you can have whatever you want input here, and it will give you the dogleg severity to land at an additional 2 points. Okay, where the projection tool comes in useful is we can append this projection onto our survey by selecting Append to Survey. You'll now see that this green line with our projection has appeared on it. Once it's in our survey listing, we can also view it on our plots. So in this case, our 3D plot, we can see our projection here in green, and we can cycle up and down it using the up and down keys. You can see how very quickly this will become a powerful tool. If I go back to my survey listing, we can see that I cannot enter any surveys while this projection's here, so I need to remove this survey. It's best not to just select it and delete it. You're better off going to your projection dialog and selecting Remove from Survey. Okay, and that removes it from your survey, and you can then go ahead and type in surveys as you would normally. What we're going to do at this stage is we're now going to take the dataset data and just copy and paste in the remainder for the curve lateral survey section. Hit save. Okay, so in this case we've landed off. Just look at that very quickly. Okay, good, well. And that's where we've landed off at the end of the curve. Next, we're going to add the final survey station in here. So right click on our actual wellbore, insert new survey. Type 4 lateral. Tie on from the previous survey and select my survey instrument, which in this case is going to be MWD plus IFR1 plus SAG plus MS. And then I'm going to open up my survey. At this point I'm going to copy and paste a handful of surveys and save, so that we're partway through the lateral. And then open up my 3D plot. Okay, again, open up my 3D plot, and I'll try and turn on my offsets. And I can't turn on any offsets. Why is this the case? Because I selected my offsets on the previous survey. Well, that is because the offset selector for each level of the database tree, so an actual wellbore as individual surveys, have their own offset selection. So you can have different offsets selected for your surface surveys versus my lateral surveys. And that's the case of why we don't have any offsets selected. We've just created a new survey. We now need to select the offsets for it. So I'm going to select my principal plan for my well and all of the relevant offsets. Okay, now that I've selected the offsets, I can turn them on. I'm going to center on my survey. Show closest approach. Okay, so again, we're now in a position where we're midway through the lateral, and I'm going to show you a couple of other of the projection tools. So again, to use projections, you select the survey table in question, go to Tools and Projection Tools. So we'll go into the multi-project dialog again. This time we're not going to be using the landing data because we're not trying to land off, we're in the lateral, but it will introduce you to the multi-nudge projection tool. So in here, if you select the method drop down, we have 5 different options. We've got the hold, closure length, or course length, where you can put in a fixed value and it will hold the same inclination azimuth for a given distance. You can put in another projection on top of that. So this tool is effectively so you can add projection after projection on top of each other, and you see it accrues in depth. So another method is course length, dogleg severity, tool face offset. So for a given course length, and I put in a tool face of 30, dogleg severity of 3, it makes that projection for us. We can then go ahead and append both of those projections, or as many projections as you like, consecutively from this listing to your survey, and then view the result of those. So that is what the multi-project function is for. Okay, I'm going to go ahead and remove those from the survey. Something else to note is this dialog can be minimized and maximized, so you can have that sat there in the background whilst you do other paperwork. And if you're in a scenario where you've got a large survey offset from your bit, and you may have a survey offset that's greater than a stand in length, you keep putting in the same projections that involve a slide and a rotation, then another slide over that interval, you can store that same projection method in here in multiple lines. So when I close it, open it back up again, that projection method is still there. And all you have to do is make sure that your tie-on line is your last survey and you're good with your next projection. Okay, the other projection tools we've got are in Tools, Projection Tools, and Project Ahead. And this effectively is an offshoot of our planning tools for the well planner. You've got your tie-on line, which is your last survey, and in here you've got the various different planning tools: optimum align, dogleg tool face, build turn, hold, adjust. There are a few bespoke things that are different to the planning tools in here. They're actually very useful that I'd like to point out specifically. I would always have the stack projections option enabled. This allows you to put in one projection, add it to the survey, and then that projection becomes your tie-in point. So effectively you can put in multiple projections, calculating them one at a time. The first method I'd like to point out is the adjust. Now this is fine, it's just like the adjust method is putting in an MD Incanasi. But something in addition to that, we can put in either a measured depth, course length, or a TVD. Just going to put in a 100-foot course length. And this trend over option. So you can effectively look at the trend, i.e. build and turn rate, over the last X number of surveys. So if you're in the lateral, this is quite useful. And use that, calculate it, and it will come up with a projection based upon your last 5 surveys, average trend, a projection based upon that. So this is probably a better tool than using your standard hold, which just uses your azimuth. This uses your trends. Again, you can add that to survey, look at the resulting in the 3D view. The downside of the project ahead versus the multi-project dialog is that it is not minimizable. You have to close this dialog before you can go and do other things. But what I told you about the stack projections is that now my tie-in line is the same as my last projection. So I could run another projection. Add that to survey. And so we're building up multiple projections through sequences of calculate, add to survey. Okay, I'm going to remove those from the survey. Another very useful tool is the dogleg tool face, point, and get back to plan by a specific measured depth. So let's say if we wanted to get back to plan by 16,000 feet, calculate, it gives us the dogleg severity and the tool face we'd need to go upon to get back to plan. But it also tells us that we get back to plan on a 95 degrees ink. So obviously, situationally, this is very useful, but you've got to be aware of the results that it outputs, the inclination and azimuth. It will get you back onto that plan as. Okay, the other method we've got here that I would like to point out is that very similar, but with optimum align. And again, this is get you back to plan by a specific measured depth. And you've got, with optimum align, you have to select the method by which you'd like to get there, either curve, hold, curve, or curve, curve. I'm going to select a curve, curve, and balanced, calculate, and this will then get me back onto the plan at a much more reasonable inclination and azimuth, and tie in with where I need to be. Okay, I'm going to add that to the survey, and then I'm going to have a look on my 3D view, and you can see this gets us back to plan on plan. So those are the projection tool methods I would like to point out to you, and those are exceedingly useful little bits of kit to have in your back pocket for figuring out how to get back to certain locations, your landing points. Another thing that's this all synergizes with really well is the real-time anti-collision dialogue. So we can put in our surveys and compare them to other wells. We can put in projections and visually compare them to the position of other wells. When we add in real-time anti-collision, this becomes an even more powerful tool. So if we go back to our survey, we select RTAC from the toolbar. This opens up the real-time anti-collision dialogue. Okay, just to give you a brief overview of this interface, you have the point of interest, and that's either your deepest survey or deepest projection on the survey listing. In the case of when you've got the 3D view selected, it will also be the point of interest that you've got selected. So I've changed it down to 15,000 feet, and the point of interest has changed. So you can move up and down your wellbore in the 3D view, and you can change your point of interest in the real-time anti-collision. The fact that we've got projections here effectively means that you can do real-time anti-collision scans for projections of where you're going to be before you've drilled there. So it's very useful in that sense. To make it the most useful, select the Calculate Separation Factor option. This then adds in separation factor calculations to your results table. You can set warning levels here, so anything that falls out with the warning level distances or values will be flagged up in red, as is the plan in this case. And that is because we are further than 30 feet centre to centre distance away from the plan, okay, which was set as a warning level of 30. If I change that to 50, it becomes unhighlighted. So that's how the warning levels system works. You can also sort these based upon no sorting, or the smallest separation factor to largest, or centre to centre distance. The real-time anti-collision dialogue is covered in more detail within the anti-collision training that isn't covered as part of this video. But it's just to make you aware, when you combine your surveys, projections, 3D view and real-time anti-collision all together, it becomes a very powerful tool for using whilst drilling and monitoring your wells. There's another visualization tool within WellSeeker Pro. You can also view your casings, your lithologies and annotations either in the 3D view or any of the other plots that we've got. In order to do that, at the actual well level, you've got the casings table, the annotations table and the lithologies table. Just going to open up the casings table. Effectively, whatever you fill in here will then be input in the software, and you'll be able to view casings, annotations and lithologies for that specific actual well and any of the surveys underneath that. So in this case, the plan already came in with values. So I believe these values are included in the dataset document included with the course, but I'm just going to copy and paste these from the plans table to the actual wells table. Now if you're copying and pasting from another well, be aware, don't copy the measured depth, because the measured depth will be different from a plan to an actual, but the TVD should be the same. So I'm just going to go ahead, Control C, select the TVD column, and based upon the TVD, it will calculate the measured depth for this particular well. Okay, I'm going to do the same for the lithologies. I'm just going to take the TVD sub C, I'm going to call these lithologies 1, 2, 3, 4, 5, 6, 7. Copy and paste those, and open up my methodologies and paste those in. And again, based upon the TVD sub C, the measured depth and TVD are automatically calculated. Once I have these in place, my casings for the 9 and 5/8 are now displaying on my 3D plot. I'm going to open up my section view chart, and again I have these automatically turned on. In order to visualize them, you would double left click on the chart to open up the chart properties, or select this chart properties icon here. You can turn on your annotations, your lithologies, your casing symbols in this section here. Just turning on my lithologies. So again, this is all pulled out of the data tables we've just input the information into, and this is where these formation tops come from. So just a little visualization information there. One other thing in terms of visualization that we can add whilst drilling your wells is geosteering data. So we already looked at offset plans and how you can create a new plan. Geosteering data is another way of visualizing geosteering data that the geologists have given you in real time. And within your data set, there is a set of geosteering data that we're going to input just now. So to input that, you go to your actual wellbore, right click, and go to geosteering updates. Okay, I'm going to go to the dataset sheet and copy and paste in the measured depth column first. I'm then going to put in my start TVD for the center and the dip angle, paste in as well. So this is effectively mass importing data. You would probably be getting these row by row from the geologist in real time. And effectively, you then input the thickness of the various parts of the target. So you've got your target thickness, i.e. the good pay zone you want to stick in, and then a top layer that might be a secondary allowable distance, and then the bottom target. So you can break this into 3 different segments. The main target centered around your center TVD. Okay, once you're happy with your inputs, hit apply and open up the chart properties, and to make these visible, select the top target, target zone and bottom target options. Okay, and we can now see within here we have some geosteering data displayed within our 3D plot. Okay, the same is useful in the section view plot. If I turn it on, and this just, again, it's another visualization tool of updates that you get from the geologist and how you can input that within WellSeeker. Okay, the very last thing I'm going to do here is show you about reporting. So I'm going to go ahead and delete those projections. In order to do that, I'll go to the projection method I used and remove from survey. Something you may have noticed that we don't have in the actual well compared to the plan is that actually when we view our 3D plot, turn on our offsets, we can't actually see the lease line or any of the targets. If I open up my chart properties, in the targets section, there aren't any targets listed, even though we've got display targets on. So effectively what this means is we don't have any targets associated with this particular well. If I select the plan, open up the targets dialog, we can see there are targets here. And if I toggle the lease lines, I can see there's a lease line here. If I go to my actual well level and open the targets dialog, it's empty. So we don't have to recreate these targets. Effectively, all we have to do is select them to be visible in our well, because they already exist under the plan. In order to do that, we adjust our filter setting. So right now, it's only set for this well. If we move it back to well level, we'll now see the ones that are available in our plan. All we have to do to make them visible in our well is select actual plan checkboxes and go back down to actual plan level, and we can see they're now associated with our actual well. If I do the same for lease lines, we don't have anything associated with this well. Toggle the filter so I can view all of the targets that are available at well level and check the actual and plan. Cycle it back so I'm viewing associated with my actual well, and again, so I've got my lease lines and my targets all down at my actual well level. And now, because I have targets turned on by default, we can see my lease lines already in place. If I turn the target names on, we'll also see that they're visible on our 3D plot. In order to create either error ellipse reports, anti-collision reports, survey reports, or planning reports, you would open the table you want to create the report data from, go to reports, and select the relevant option. So most common will be the survey reports and the anti-collision reports. I'm going to select survey reports here, and you have a few pre-designated report templates to use, but you can go ahead and create your own using these options here. Okay, I'm going to select the standard survey report layout. The output here is either PDF, Excel, or a text file. And you can select the columns that will appear in your report, as well as general layout options. You can also select to interpolate at different intervals, over depth ranges, and various other options here. You can also adjust the colour of your report for the PDF, and the option for your colour of your Excel reports is selectable here. You can also select portrait or landscape and printing options. So I'm just going to go ahead and very quickly create, but in your own time you can play around with the layouts, and it will use your default PDF viewer to display your report. Okay, so that covers the basic directional drilling tools available within WellSeeker Pro. What we're going to do now is go ahead and do a few question and answers, and then you'll have an exercise to complete to finish off this section of the course. Now we're going to go through some questions to see if you managed to pick up all the information from the video. For any of these questions, if you don't know the answer, pause and go back and look at the video to find the answer out before restarting the video to find out the answer. Okay, so first question. What methods can be used to input database tree information into WellSeeker Pro? And the answer is you can manually input that data. You can use a WellSeeker export file, a Compass export file, and you can also, if you've got a server set up, use remote data fetch to populate your database tree information. Next question. In relation to a reference well, what does selecting offset wells and plans achieve? And the answer, when an anti-collision report is created or the real-time anti-collision dialog is opened, these offsets will be the only offsets included in the results. It also allows the offsets to be toggled for view in plots. So that's what selecting the offsets does. Next question. When updating a depth reference for a plan or actual well, Which option would I select if I wanted to keep the TVD subsea values the same, but change the TVD values? And the answer, change TVDs. And the last question, what is the best way to remove a projection from the survey listing? The answer is, in the projection dialog that was used to create the projection, select Remove from Survey. Now for the end of video exercise. Effectively, you'll be going through a very similar process to what was covered in the exercise. So first step, open WellSeeker Pro and select the provided database file. Visualize the plan in the 3D plot, and when within the 3D plot, select offset wells and make them visible. Center on survey and show closest approach for your reference well. Move up and down your reference well. Change the offset well being referenced, and open up chart properties and have a play with some of the settings. Then open the separation factor plot and identify any offset risks. Change the plan depth reference. Create an actual well and input the properties data. Create and input survey data down to midway through the curve section. Project to land off 20 feet deeper than the plan. Add a projection to the survey, and then view on the 3D plot and view in the real-time anti-collision dialog as well. Once you've completed that, remove the projection from the survey. Then create and input survey data down to midway through the lateral section. Project to get back to plan by a given measured depth. Create an offset plan landing 10 US feet TVD shallower than the principal plan with a dip angle of 88 degrees. Input all the survey data to TD, and then once that's done, input the geosteering data provided in the dataset. Once all of that is complete, create a survey and an anti-collision report, whether it be in PDF, Excel or text. If at any point you become stuck, refer back to the video that you've just watched for a refresher to find the answers and a little way forward. That completes the directional drilling tools video.